PHP is a powerful, free, open-source web scripting and programming language. It's widely used in the web development industry as a result of its speed, stability, and cross-platform compatibility. This means that PHP can run on a Linux production server, a Windows development server, and on a Mac testing server. For the purpose of these lessons, you'll need the WAMP or MAMP testing server installed on your system. If you're taking this course as part of the Web Development Masterclass, you might recall that we did this early in the course. In the next lesson, we'll talk more about making the necessary preparations for hosting your PHP scripts. It's important to note that PHP processes scripts on the web server. This is unlike JavaScript, HTML, or CSS that process scripts on the client side or a web browser. Let's take a look at how PHP works through an illustration. Say, for example, we were visiting a web page from our home computer that contained some PHP code. Our request travels through the web to the web server hosting the website and all of its files. In order to process our request, the web server requires various components to execute the PHP script. First, the web server would need Apache installed to intercept the request and retrieve the PHP file from our web server. Apache would then parse the file and determine that certain parts of the page have PHP code that need to be executed. Apache has a PHP plugin built in that can execute the instructions contained within a PHP script. As an example, a common set of instructions include retrieving and inputting data into a database, although the script can be something as simple as a basic calculation. Regardless, Apache returns the script and renders the page as instructed by the PHP code. It then sends the file back through the web to your PC and ultimately to your web browser. Note that in this diagram, we illustrate the database as a MySQL database. This is a popular type of database that is commonly used with PHP. We'll explore MySQL databases and database queries in the next section of this course. If you're currently taking this course as part of the Web Development Masterclass, you might recall that in the beginning of this course, we installed the WAMP or MAMP testing server on our local machine. We did this specifically to be able to test our developed PHP scripts on our computer without having to upload them to a production server. If you have not done so already, launch your WAMP or MAMP server. To do that, double-click on the icon that looks like this. This icon may be on your desktop, but if not, then you can access it directly from the file path listed below or through your Start menu. The server will launch and you will see a small icon appear on your system tray. When the icon turns green, it's an indication that the WAMP server has successfully started up and is running. If you need a refresher on how to configure the WAMP or MAMP server, refer back to our section on setting up your testing server. In order for us to test our scripts, we need to make sure that we store our PHP scripts inside the web root folder contained within the MAMP or WAMP directory. When you install WAMP, the main folder is typically created inside your C drive. So you'll need to open this folder. So I'll go ahead and access it. So here I'm in the C drive, and as you can see, I have the folder WAMP listed here. If you're on a Mac machine, you'll have MAMP. If I double click in there, we can see the www directory. This is a very important folder. All our websites need to be stored in this folder. It's referred to as the web root folder. It's best to organize all your websites inside this folder. So for example, if we have 4 websites, we would create 4 individual folders that would contain the contents of each site. For the purpose of this course, make a folder called PHP Lessons. We'll store all our PHP scripts in this folder so we can test them as we progress through the course. In this lesson, we will create a basic PHP file that outputs some text into our web browser. The first thing we need to do is confirm our WAMP or MAMP server is configured correctly. To do so, simply open your web browser and type localhost in the address bar. You should then see this page displayed. This is the default WAMP page. It provides some important information about the server configuration, including the Apache and PHP version. It also lists some tools that are included in your package. We'll be using these tools in the next section when we work with MySQL database. The page also lists the websites contained in your web root or www folder. Here, we can see the folder we created in the last lesson, PHP Lessons. Remember that this is where all our files will be saved for this section of the course. To make sure your scripts are working correctly, open Notepad++ and type in the code displayed on the screen. We'll discuss the actual code in the next lesson. This file will just output the text "Hello World" in our web browser using the PHP echo command. When you're finished typing in the code, save the file in your PHP Lessons folder as intro.php. You can actually give it any file name, but the .php extension is very important. PHP files will not work unless the .php extension is included. You'll notice we've embedded the PHP code in HTML. But even so, we still need to specify the PHP extension. We cannot save it as an HTML file. Type in the following into your web address: localhost/phplessons/intro.php, and press enter. You should now see the text "Hello World" displayed in your web browser. PHP code can be placed anywhere inside a document. It can be placed in any HTML tag, including CSS. A PHP script starts with the open PHP tag and must be closed with the closing tag. In this PHP tag, we have an echo statement. This statement will display the content inside the quotes. In this case, "Hello World." A PHP statement must end with a semicolon. We've also embedded an HTML tag, the HR tag, inside the echo statement. This will display a horizontal line after our "Hello World" text. And here it is in our web browser. We can see the text "Hello World" with the horizontal line beneath. We can create comments in PHP that are not read or executed as part of the page in our web browser. The purpose of a comment is to provide information to a programmer analyzing the code. Comments are very important in PHP because scripts can become lengthy and complicated, especially to someone who's trying to understand the functions or arithmetic that you've coded. In this example, we've illustrated 3 different formats for creating comments. The double slash and number sign can be used for single line comments. We can create multi-line comments using the slash and asterisk combination. And so you can see that none of this is actually displayed in the web browser. It's only for somebody interpreting the code. We can insert comments inside arithmetic to leave out parts of a code line, as shown here. We have the equation x is equal to 10 plus 5 plus 20. As you can see, 5 has been commented out. So the result of this equation will be 30, as seen in our web browser, because we're only adding 10 plus 20. For now, don't worry about variable declaration. We'll be covering that independently in another lesson. PHP is not case sensitive when dealing with classes and functions such as an if statement, else statements, while, and echo statements. In this case, each echo statement would work despite differences in case. So in the first example, we have echo in capitals, and the desired output is text sample 1 with a horizontal line underneath. And we can see that it outputs just fine. Next, we have lowercase echo. And it's the same line that we're outputting. Just change sample 1 to sample 2. And we can see that it outputs fine as well. Lastly, we have echo with the E and C capitalized and H and O lowercase. And the output text sample 3 with the horizontal line underneath is outputted. Note, however, that variable names are case sensitive. In this example, we have a variable named car, which contains the value Volvo. We then have 3 echo statements, each time changing the case of the variable output car. Only the first line will output the variable correctly, because the case does not match in the second and third line. So we can see here in the first line, the variable to be outputted matches the case of the variable itself, and so it outputs correctly, my car is a Volvo. In the second and third example, the case does not match, and for that reason, we receive 2 error messages, undefined variable car, and once again, the same message here. Notice that the case is incorrect. And that's why we get those messages. If you're unable to see error messages, you'll need to do the following. Click on your WAMP or MAMP icon. Go to the PHP menu. Select PHP settings. And make sure there's a check mark next to display errors. If that's not there, then you will not see error messages in your web browser. In this lesson, we'll be discussing PHP variables. You can think of a variable as a container for storing information. Variables can store both numerical and text data. In this document, we have some PHP embedded in the body of our HTML. In PHP, a variable declaration must start with the $, followed by the variable name. In this case, we've named the first variable var1. The var1 variable contains the value hello world. We also have 2 other variables declared, x and y. X holds a value of 15 and y holds a value of 20.5. There are some basic rules when naming variables. A variable must start with the $, followed by the name of the variable. A variable name must start with a letter or the underscore character. A variable name cannot start with a number. A variable name can only contain alphanumeric characters and underscores. Variable names are case sensitive. When working with variables, the PHP echo statement is often used to output the data. Here, we've outputted the values contained within each one of the variables we declared, and this is done using the echo statement. We can see that we're outputting the value of var1, followed by an HTML break, and then the value of x, break, and then the value of y. Lastly, we'll be outputting a horizontal line. And you can see the output here in our web browser. Hello world, the value of x, which is 15, and the value of y, which is 20.5. We can also output a combination of variables and text. So here we've declared a variable named sport containing the value football. Next, we have an echo statement which outputs the words I like, and then the value of the variable sport, which in this case is football. And we can see the result over here. This is the final output, and we also have a horizontal line, which you can see. We can also use another output method to achieve the same result. So here we have the same variable name, sport, and the same value, football. The only difference is in the format of the echo statement. In this next example, we output the value of one variable added to another. In this case, x plus y. That's what we have in our echo statement. X has been assigned the value of 5, and y has been assigned the value of 6. Notice that we don't have to put quotations around numerical values. And when we add the values together in our web browser, we see that 11 is displayed. When programming in PHP, you'll often work with functions. A function is a block of statements that can be used repeatedly in a program. Functions can be used to perform many different types of actions, and PHP has thousands of them built in. We'll be exploring functions later in this course. For now, it's just important to know how to work with variables inside and outside a function. A variable that is declared outside a function is known as a global scope variable. It can only be accessed outside a function. In this example, we've declared the variable x with a value of 5 outside the function test1. This means that it's a global variable. The purpose of this function is to output the value of x, and we have an echo statement here to do that. Since x has been declared outside the function, the output will not work. It'll produce an error as shown here in our web browser. We can see that the error says undefined variable x. So it does not recognize the variable. Now, in contrast to a global scope variable, we also have local scope variables. A local scope variable can only be accessed inside a function. In this example, we have a function named test2. Inside this function, we've declared variable y and assigned a value of 5. If we try to output the value of y inside the function, then we can see in our browser that it does work. So on the right side, we can see this statement here, value of y is 5. And that corresponds to our echo statement, where we're trying to output the value of y. Since y is declared inside the function, it works. This is a local scope variable. But if we try to access the local scope variable outside of the function, so here we have a separate echo statement where we're trying to output the value of y again, but this time outside the function. Well, this is going to result in an error. And you can see on the right-hand side here that it does not output the actual value of y. It gives us an undefined variable error. So that's the difference between global scope and local scope variables. The global keyword can be used to access global variables that are inside a function. In this example, we have two global variables, x and y. X with a value of 30 and y with a value of 20. Inside the function named test1, we've used the global keyword to access the values of variable x and y. To confirm that this worked, we've set variable y equal to the sum of x plus y. So we'll go ahead and execute this function by calling function test1, and also by outputting the new value of variable y, which we know should be 50, which is 30 plus 20. So we can see in our web browser that 50 is in fact outputted. So the global keyword has worked for its purpose. It's important to note that PHP stores all global variables in an array variable called globals. An array is a special variable that can store multiple values. We'll be exploring arrays later in this course. The array index holds the name of a variable. So we can rewrite our existing code as follows. So we can see that here we're referencing global variable y, which we're setting to the sum of global variable x plus global area y. And once again, the output should be the exact same, 50. When a statement is executed inside a function, all the variables and corresponding variable values are deleted. In certain situations, we want local variables to retain their value so they can be used elsewhere. To do so, we can use the static keyword when declaring the variable. As shown in this example, we've set up a function named test1. Inside this function, we've declared a static variable x and assigned an initial value of 10. Next, we have an echo statement to output the value of x, followed by the x++ statement, which will increment the value of x by 1 every time the function is executed. As we can see here below, we've executed this function 1, 2, 3, 4 times. Each time it outputs the value of x plus 1, starting with an initial value of 10. So you can see that in our web browser, the initial value is 10, which is also the initial value of our x variable. Since we've used a static keyword, that variable value is stored, and every time the function runs again, it takes that stored value and adds 1 to it. So after the initial 10, we'd have 11, 12, and 13, and that you can see is correct. It's in our web browser. With PHP, there are two ways to get output. We can use the echo or print statement. Both these output methods are relatively the same. The main difference is that echo allows multiple parameters in a statement and print does not. We'll come back to this in a moment. Echo also executes statements slightly faster than print. In this first example, we've used an echo statement to output some text contained within the HTML h1 tags. The HTML tags must be contained inside the quotes along with any text. And you can see the output on the right side here. This is the test header in this echo statement. Next, we have another echo statement with some text followed by an HTML break tag. So again, we're embedding some HTML inside our quotes, and you can see the output for that statement here. The third echo statement contains multiple parameters. We can see each parameter enclosed in quotes followed by a comma. So you can see the first parameter, the second, the third, and the fourth. And they're all connected by commas to form a sentence, as seen in the output over here. So the print function does not allow this method with multiple parameters. And even using the echo statement, this is very rarely used. And lastly, we just have an echo statement with the HR tag, and that just gives us the horizontal line as a separator. We can output variables using echo. So in this example, we've declared 4 variables: text1, text2, x, and y. So text1 and text2 hold text strings, whereas x and y hold numerical values. Text strings, of course, have to be enclosed in quotations, where numerical values do not. In our first echo statement here, we've outputted the variable text1 inside HTML header tags. In our second echo statement, we've outputted the words I like, followed by variable text2 and an HTML break. The third echo statement outputs the sum of variable x and y. And so we can see the results of these 3 statements right over here. So this is the first echo statement with the header 2 tags. This is the second echo statement, and the third. The third is the sum of x and y. The next set of examples do the same thing as what we went over above, only this time it's using print instead of echo. And as you can see from the output, as you go through the code and also the output on the right side, the results are identical. The only difference is we've replaced the word echo with print. The statements are the same as well, and so you can go through that and see how there's really not much difference at all. We can store variable data into different types of variables. Each variable data type has its own unique characteristics and can be used for different things. In this lesson, we'll explore the following data types: string, integer, float, array, null, boolean. We'll explore the object data type in the next lesson. In our first example, we've declared a variable x and assigned the value hello world. This is an example of a string variable because the value is a sequence of characters. We can declare a string variable using single or double quotes. Variable x is enclosed in double quotes, and variable y is enclosed in single quotes. The value is identical and the output is also identical. We've used the echo statement to output the value of variable x and the value of variable y. We can see the output is the same. An integer data type is a non-decimal number. There are certain rules for an integer. An integer must have at least one digit. It cannot have a decimal point. It can be either positive or negative. And integers must be specified in one of three formats: decimal, hexadecimal, or octal. In this example, we've declared a variable called num as an integer with a value set to 6,000. Notice that the value is not enclosed in quotes. Integer variables do not require quotes. Next, we've used our var dump statement to output the data type and value. In our web browser, we can see the variable num is an integer with the value 6,000, just like what we specified. The next data type we have is a float, also known as a floating number point. A float is a number that is in exponential form or that contains a decimal point. In this example, we've declared variable num2 and assigned the value 20.565. Since the value contains a decimal, our var dump statement will output the data type as float. And this can be confirmed over here. We can see that num2, the num2 variable, is a float and the value is 20.565. An array variable can store multiple values. In this example, we've declared the variable sports as an array with 4 values assigned: soccer, tennis, baseball, and football. Using our var dump statement, we can output each value in the array. We'll be working a lot more with arrays later in this course, but for now you can see that with var dump, it specifies that the array size is equal to 4. We can see each index number in this array, 0, 1, 2, and 3, and its corresponding value. And the values are what was specified in our array. So if you find that confusing, don't worry, we will be working a lot more with arrays later on. The PHP null value is a data type that can only have one value, null. The null value type means the variable has no value assigned to it. We can also empty the value of an existing variable by setting the variable value to null. In this example, we have the variable color with the value assigned initially to blue. We can empty this value by setting the variable to null. So you can see that when we use the var dump statement, it outputs the value null because we've converted the value blue for the variable color into a null value. A Boolean variable can only hold 2 values, true or false. Booleans are used primarily in conditional statements such as if statements, else, and else if. We'll be exploring conditional statements later in this course, but as a general rule, the following values would be considered false. A Boolean that is set to false, as shown in this example, variable y is set to false, so the value of this Boolean would be false, as indicated here. And you can see variable x is set to true, so the value of this Boolean is true. The integer 0 would have a false value. The float 0.0 would also be false. An empty string, an array with 0 elements, a null variable, these would all be considered having a false value. With a couple of exceptions, almost any other value would be considered true. An object data type stores data and also information on how to process the data, known as a method. As an example, a car could be considered an object. A car has certain properties, such as make, model, color, weight, and so on. A method would be considered anything that the car can do, such as travel, turn, stop, or slow down. As a rule, an object must be explicitly declared. The first step to creating an object is to create a class. The class is the set of properties or variables that are tied to an object. In this example, we have the class person. Next, we've defined some properties that the person has. The person object has 3 properties: a first name, a last name, and an age. You'll notice in front of each property we have an assignment called public. There are 3 different types of assignments, including public, private, and protected. Next, we've constructed a function that tells our properties what values will be assigned to the variables: first name, last name, and age. In this case, each time a new person is created, is seen here, the first value contained inside the parenthesis after the new person declaration will be the first name. The second value inside the parenthesis will be the last name, and the third will be the age. Each variable here, person 1 and person 2, creates a new person. Each person has their own unique set of information. We have a method inside our class, and a method is a function tied to an object. This method, which we've called hello, will output a sentence with the person's first name, last name, and age. We've called on this function at the end of our script here. We can see the statement echo person 1 hello. We also have echo person 2 hello. In our web browser, we can see the values of the properties first name, last name, and age have been outputted based on the number of new persons we created, which in this case was 2. And that is how an object works. Note that these values would typically be derived from a database. In this lesson, we'll explore some commonly used functions that apply specifically to strings. We can count the number of words in a string using the string word count function. Here, in the string hello world, we know is 2 separate words, so the output would be 2. We can reverse words in a string using the string reverse method. In the string hello world, the output in reverse would be as follows. We can see that here. The PHP string position function searches for specified text within a string. In this example, we're searching for the word world inside the hello world string. The output in our web browser is 6 because the word world starts at the 6th character position inside the string hello world. So we have 1, 2, 3, 4, 5, and 6, and then world begins. The string replace function will replace a word with another specified word. Here, we've instructed the function to replace the word world with the word John. So what would have originally outputted as hello world will now output as hello John, as seen here. A constant is an identifier for a given value. A constant cannot be changed during the script as a variable can. Also, unlike variables, a constant is automatically global across the entire script. When creating a constant, the name must start with a letter or underscore. A constant does not require a $sign before the name. As shown in this example, a constant can be created using the define function. Inside the function, we start with the constant name, followed by the value. We can also specify whether the constant name should be case insensitive. We'll do that in the second example. In this example, the constant name is set to welcome. The value is the text, "Hello, my name is John Smith." The constant name is case sensitive. We can output the constant by creating an echo statement followed by the constant name, welcome. If we were to set the echo statement to lowercase welcome, the output wouldn't work. First, on the right-hand side, we can see here that the output is correct. It's outputted the value, "Hello, my name is John Smith." But what if we were to change from uppercase to lowercase? Now it does not match our constant name. Well, the case doesn't match. And now we get an error because the case doesn't match. So we'll change it back. In the second example, we've set the case insensitive value to true, shown here. This means when we output our constant, in this case, welcome to, it doesn't matter if we use uppercase or lowercase for the constant name. So you can see that the case here doesn't match in the echo statement. And when we refresh, this time it still works. Constants are global and can be used across the entire script. In this example, we've defined the constant with the name car and set the value to Volvo. We've also created a function, myCar, that outputs the value of constant car using an echo statement. When we run the function, we can see that the browser outputs the value Volvo. Operators are used to perform various operations on variables and values. In this lesson, we'll do an overview of several operators. It's important to note that PHP divides operators into the following groups: arithmetic operators, assignment operators, comparison operators, increment and decrement operators, logical operators, string operators, and array operators. Because of the amount of operators that can be found across these groups, we'll go over a few examples in each group. The file used in this lesson is located in your Downloads folder. You can use it for future reference and also go through each operator if you require further information. We'll start with arithmetic operators. The first section in our PHP file provides an example of the different arithmetic operators available, including addition, subtraction, multiplication, division, and modulus. We can see the output of each echo statement in our web browser. So for example, we've set variable x to equal 50 and variable y to equal 20. The first example here, the first echo statement, uses the addition operator to add the value of variable x with y, and the output is 70. The second example subtracts x minus y, and our output is 30. So it's fairly straightforward. Going down the file, the next operator we have here is the assignment operator. An assignment operator is used to set the value of the left operand to the expression on the right. In this equation, we have variable x, and we use a single equal sign to assign the value 20 to x. So if we were to create an echo statement and output the value of x, well, it would be 20. So we've set the right expression, we've set that value to x. And that is known as an assignment operator. It assigns the value over. Comparison operators are used to compare two values, numbers or strings. In the first example, we've set the value of x to 300 and y to 300 with quotes. Okay, so no quotes and quotes. We've used the var dump function to compare x to y using a double equal sign. The double equal sign is going to check if the value on the left is equal to the value on the right. And because 300 is equal to 300, our output is true. The next operator is three equal signs. So the variable of x and y are set to the same values again, 300 and 300 with quotes for y. Three equal signs will check to see if x is identical to y. And we know it's not identical because y has quotes surrounding it. So the output is false in our web browser because they are not identical. You can go through the remainder of the comparison operators to see the result. They're fairly straightforward, and the comments explain what each one does. Increment operators are used to increment or decrement the value of a variable. If we take a look at the second example, we can see that the initial value of x is set to 50. Using the ++ x, in this case, so if our variable was named anything else, we'd replace x with the variable name. We can increment the value of this variable by 1. And you can see on the right-hand side, 50 has been incremented by 1 for a result of 51. In the next example, we can see that we've decremented the value of 50. So x is again equal to 50, and using the minus variable operator, we have decremented by 1 from 50 to 49. Logical operators are used to combine conditional statements. So in the first example here, we have two variables, x and y. X is set to 200 and y is set to 300. We then use an AND operator to check if x is equal to 200 and y is equal to 300. We'll be working a lot more with if statements later on in this course, but in a nutshell, we've instructed the script to output the word true if both these conditions are met. And in this case, the conditions are met, so in our web browser, we get an output of true. In the second example, everything is more or less the same. The difference is we use the OR operator. So if x is equal to 200 or y is equal to 90, we'll output the word true. Since one of these conditions are met, x is equal to 200, we get an output of true. And that's how the logical operators work. There's a few others you can go through as well. Next, we have string operators, and these are specifically to be used with strings. The first example here allows us to attach one string variable to another. In this case, our web browser will output hello and world on the same line. it's attached the value of x with y using the period there. And so you can see the output here, hello world, on the same line. Now we have array operators as well. Array operators allow us to compare and manipulate arrays. In the first example, we've created a union of two arrays. So we have array x and array y. Array x has its own set of values, blue and red, and array y has its values, pink and brown. And using the plus sign, we've created a union of the x array and the y array. So we can see in the output that all the colors of both arrays are listed. And you can go through the other array operators as well. Some of these operators we'll be using in different sections of this course. So again, there's a lot here. It's a fairly long script, and it's more for reference purposes, and you can definitely go through it and see what each one does. All the outputs will be in your web browser when you preview the file. In this lesson, we'll be exploring conditional statements. When writing code, we often want an action to occur based on an event or condition. In PHP, we have different types of conditional statements, including if statements, if-else statements, if-else and else-if statements, and switch statements. We'll start with an example of a basic if statement. Here we have a variable x set to the value of 49. We've created an if statement with one condition. If the value of x is less than 50, we want to output the words condition met. Since 49 is less than 50, we can see in our web browser that the words were outputted. Condition met. Now, what would happen if the condition was not met? Let's say we set x to 51. In this case, 51 is not less than 50. So there's no output in our web browser. There's no output because we have not instructed our script on how to handle this situation. To do so, we can add an else statement. Let's create an else statement that outputs the words condition not met if x is not less than 50. So let's recap what we've done here. If x is less than 50, output condition met. If x is anything else, and there can only be one other thing, that x is greater than 50, output condition not met. So we can see in our web browser that it now outputs condition not met because x is not less than 50. You can change the value of x to test different results. In this lesson, we'll explore a more complex set of conditions. Say, for example, we wanted to create a grading system that converts a student's test score out of 100 marks into a letter grade. First, let's define our grading system. Let's say that any mark under 50 is an F. 50 to 59 is a D. 60 to 69 is a C. 70 to 79 is a B. 80 to 89 is an A. And anything over or equal to 90 is an A+. Now we can start creating our if statements. We start with if and create our first condition. If variable x is less than 50, then output an F. Next, you'll see a series of else-if statements. An else-if statement is used if there are more than 2 conditions. In this case, there are 6 conditions. The second condition states that if x is greater than or equal to 50 and if x is less than 60, output a D. Next, if x is greater than or equal to 60 and x is less than 70, output a C. If x is greater than or equal to 70 and x is less than 80, output a B. And if x is greater than or equal to 80 and x is less than 90, output an A. We finish with an else statement, which basically instructs our script to put an A+ in any other scenario. Since the test was out of 100, and the student couldn't get negative marks, the only other scenario can be that the mark was equal to or greater than 90, in which case we've instructed the script to output an A+. So we've set the value of x to 90, and you can see in our web browser we get an output of A+. We can test it with other values just to make sure the script is working. Let's go ahead and test 65. 65 is greater than or equal to 60, and it's less than 70. So if our script is working, we should get C. Let's go less than 50. Less than 50, and we output an F. So it looks like our script is working. The switch statement compares the value of an expression against a set of predefined conditions, also referred to as cases. If there's a match, the block of code associated with that case is executed. In this example, we have a variable with the value Volvo assigned to it. Next, we've created a switch statement pertaining to the car variable with 4 cases. In the case that the car variable is equal to Volvo, we'll output the text, "You drive a Volvo." In the second case, if the variable value is BMW, we'll output the text, "You drive a BMW." And in the third case, if the car variable's value is Honda, we'll output the text, "You drive a Honda." We then use the default statement to output the text, "You don't drive," if the car variable does not equal any of the cases defined above. So as you can see, it's relatively straightforward. Since our car variable is set to Volvo, in our web browser, we can expect the statement, "You drive a Volvo," to be outputted. If we change this to BMW, you can see that the statement now changes to, "You drive a BMW." Now, what if we put something completely unrelated? We'll change the car variable to the value Merc. You can see that since Merc is in none of the cases, it results to the default, which is the statement, "You don't drive." Loops allow us to run the same block of code multiple times automatically. In PHP, we have 4 different types of loop statements: the while loop, the do while loop, the for loop, and the for each loop. Let's start with an example of the while loop. In this example, we have a variable x with its value set to 1. We've then created a while loop that will loop over and over again as long as the value of x is less than 10. Using a post-increment operator inside a while loop, we can keep incrementing the value of x until it reaches its maximum limit in this situation, which is 9. Since x is initially set to 1, the first time the loop runs, the value of x will be 1. the second time it runs, it will increment to 2. It will continue to increment until it reaches a value less than 10, so 9. We can see this in our web browser. We can see that the loop runs over and over again, and each time it outputs the statement, the number is, and then the value of the loop at that instant. If we change 10 to 20, we'll see that the loop now runs 19 times. If we change the value of x to 5, we can see that x will start incrementing at 5. We'll change the value here back to 10. But now what if we change the value of x to a value greater than 10, say 11? We can see in our web browser that there is now no output. The while loop checks to make sure a specified condition is true first before executing the loop. So it checks to see if x is less than 10 first, and if it is, it will go ahead with the loop. If not, it will not execute the loop. Now let's take a look at the do-while loop. This type of loop is different in that it will execute a block of code once, and then it will check to see if a condition is true. From that point, it will repeat the loop only if the condition is true. In this example, we have a variable x set to the value of 6. Next, we've created our do-while loop. We specified the action, which is to echo the value of x, and once the value is outputted, we then have an increment operator that increases the value of x by 1. After the increment operator, we have our while statement and then the condition. The condition states that this loop should only be repeated if x is less than or equal to 5. In this case, it's not, so the loop will not run again, since x is actually equal to 6. Now we can see in our web browser that the loop did execute once, but there will be no further output because the loop will not run again. If we were to reduce the value of x to say 2, now the while loop will run because the value of x is less than or equal to 5. So it'll continue to run until that condition is no longer met. And that is the difference between a while loop and a do-while loop. In this lesson, we'll explore the for and for each loop. The for loop is used when you know in advance how many times you want the code block to execute. The syntax of the PHP for loop consists of 3 parameters, as displayed in the dialog box. In this example, we've created a for loop to output the value of variable x, starting from 0 and up to a value equal to or less than 10. In our web browser, we can see the output 0 right up to 10. The for each loop works only on arrays. It's used to loop through each key or value pair in an array. In this example, we've created an array variable, cars, and assigned it 4 values: Volvo, BMW, Honda, and Ford. We then set up a for each loop to loop through each value in the cars array and output the result using the echo statement. We can see in the web browser that each value in the array has been outputted. Volvo, BMW, Honda, and Ford. We can see that for every loop iteration, the value of the current array element is assigned to the variable value. PHP comes with many built-in functions. In addition to these predefined functions, we can also create our own custom functions. A function is a block of statements that can be called upon whenever they're required. A function will not execute unless we specifically call the function in our script. The syntax for a function starts with the word function, followed by the function name. We can place the function statements inside the open and close curly braces. The function name can start with a letter or an underscore, but not a number. Function names are not case sensitive. In this example, we've created a function called displayText. The function has one statement, an echo statement that will display the text my first function. To call a function, we simply write the function name followed by parenthesis and a semicolon, as shown here. We can see the final output in our web browser. The text my first function is displayed. Our second example shows how we can use functions to pass information through arguments. An argument is just like a variable. Arguments need to be specified inside the parenthesis after the function name. We can assign as many arguments as needed, but each must be separated by a comma. In this example, we've created a function named myCar with one argument, car. The function has one statement, an echo statement that outputs the value of the argument car. The value of the argument is derived when we call the function. After the function name, we pass along a value to the argument. Here, we've called the function 3 times, each time with a different value assigned to the variable car, Volvo, BMW, and Honda. We can see the corresponding output in our web browser each time the function executes. We can easily add a second argument to our function. Just place a comma after our first argument and create the second. We'll call this one color. Remember that we'll have to modify our echo statement to output the value assigned to color. The values will come from when the function is called. So we'll create values to assign to our new argument. Now I'll save the file and refresh the page, and we can see that the second argument values are now displayed. We can set default parameters for arguments as shown in this example. Here we have a function called myAge. We have a single argument assigned to this function called minAge, with the default parameter set to equal 30. Now when we call this function, if we do not assign a specific value to our minAge argument, the output will be the default parameter value 30. We can see in the remaining calls a value has been assigned. For this reason, the assigned value will be outputted in our web browser, and we can see the end result here. The first call to our function myAge outputs the default value 30. In all the other calls, the assigned value is outputted. In this next example, we've used the return statement to calculate the sum of two arguments, x and y. We can see the arithmetic operation z is equal to x plus y, then a request to output the result using the return method. We can see here that we've assigned values to x and y in our calls to the function named add. The first assignment is 1 for the x value and 2 for the y value. The output is 3. And for the second, it's 3 and 4, so we have an output of 7. And the last is 5 plus 5, which is 10. In this lecture, we'll explore PHP arrays. We've already had a bit of exposure to arrays in some of the previous lessons. An array is a variable that can store multiple values. In PHP, there are 3 types of arrays: indexed arrays, associative arrays, and multidimensional arrays. We'll start with an example of an indexed array. Here, we have a variable named colors. The variable contains 3 values: blue, green, and red. We can output each value in the array by specifying its unique index number in square brackets, as seen here. We have an echo statement, and then just some text, my favorite colors are, and then each value in the array is referenced using its index number in square brackets. An index always starts with the number 0. So the 0 in this case is assigned to the first value in the array. Blue would have the index number 0. The index number increments by 1, so the value green would have the index number of 1. And red would have the value, or the index number, of 2. We can see the output in our web browser here. We can use the count function to return the length of the number of values in an array. In this case, we have 3 values: blue, green, and red. By typing count and then the variable name, colors, we can see that 3 is outputted in our web browser. We can loop through the values of an indexed array using the for loop. First, we specify we want the value of x to start at 0 and increment by 1 up to the length of the array. And the length of the array is obtained using our count function and storing the value in a variable called rLength. And so we can see that variable here as well. Next, we simply loop through each index number in our array, which will output the value attached to the index number. And that's done here. Echo, colors, and then the index number. And we can see the output here in our web browser. The next type of array we want to explore is the associative array. This type of an array allows us to assign values to our elements, and this is referred to as named keys. In this example, we've created an associative array variable named tscore. For the purpose of this example, we'll assume tscore holds the mark that students scored on a test out of 100. Tscore has 3 elements: John, Bill, and Dan. Each element has a named key, or value, assigned to it. So John is assigned 60, Bill is assigned 80, and Dan is assigned 75. Next, we use our echo statement to output the mark that Bill got on the test. We do that using our echo statement and inserting the named key in square brackets next to the associative array name, as seen here. And in our web browser, we can see the corresponding output. Bill scored 80 out of 100. We can loop through an associative array using the for each loop. And we've gone over the for each loop before, so we can see the output displayed in our web browser, but this time with the named key value as well. In the last tutorial, we explored the associative array using a single named key. In this lesson, we'll create an array that holds multiple key value pairs, known as a multidimensional array. A multidimensional array is an array that contains one or more arrays. First, let's look at the following table. Here, we have a student's name followed by the grades each student has received on 2 tests. In our example, we've stored the data in each row in an array. The first array has the name John and his 2 test scores, followed by Bob, Sam, and Ted. We have 4 arrays in total. Each array's values can be accessed using its position in the table we looked at earlier. The value is actually its index number, but the table makes things much easier to understand. Taking a look at our first echo statement, we can see that the value John in array 1 has an index number of 0, 0. John's first test score has an index number of 0, 1. His second test score has an index number of 0, 2. Now let's output Bob and his 2 test scores. Bob has an index number of 1, 0. His first grade can be referenced using index number 1, 1, and his second test score 1, 2. Sam has an index number of 2, 0. Test 1 is 2, 1, and test 2 is 2, 2. So by now you can probably see the pattern, and you can apply the same concept to output Ted's grades as well. PHP offers different methods of sorting the elements in an array. We'll start with the sort function. In this example, we have an array called names with 8 values: John, Bob, Dana, Sue, and so on. To sort each value in the array alphabetically, we can use the sort function. To do so, we type sort and the name of the array in parentheses. Next, we can use a for loop to output each value in the array. You can see the output in our web browser, and each value is sorted alphabetically. Note that this sort function works for numerical values as well, and we can use the rsort function to reverse sort the values. So simply replace sort with rsort, save the file and refresh, and now you can see the order has been reversed. We can sort the elements in an associative array in ascending order by their value using the asort function. So here we have an associative array named tscore. Inside this array we have 3 keys and 3 values, John, Bill, and Dan being the keys, and the values being 60, 80, and 75. To sort them in ascending order, type asort and then the name of the array in parentheses. Next, use a for each loop to output each element in the array. And you can see in our web browser that we've sorted it by the value and not the key. We can sort by key rather than value by using the ksort function. And now we've sorted by key. To sort according to value in descending order, use arsort. So again, this is to sort according to value in descending order. So now we have 80, 75, and 60. To sort according to key in descending order, use KR sort. And now we can see we have John, Dan, and Bill. Superglobals are variables that are built into PHP and that are always available for use. You might recall that we worked with one such variable called globals. In this example, we have a global variable z that stores the sum of variables x and y, x plus y. X is equal to 30 and y is equal to 40. We can see the global variable is accessible from outside the function, even though it was defined inside the function. So here we have echo z, and that outputs the result, which is 70. Remember, normally when a variable is declared inside a function, it's considered a local variable and cannot be accessed outside the function. So we can see that the globals variable is an exception to that rule. There's actually quite a number of built-in global variables, and it would take quite some time to go over each one. For this reason, we've provided a couple of examples in this lesson and included the remainder in your downloads folder. The first here we have the PHP server Superglobal, and this variable stores information about headers, paths, and script locations. We can see the output in our web browser here using the echo statement. The server name Superglobal returns the name of the host server. Since this script is hosted on my local machine, we see the word localhost displayed in our browser. Other commonly used superglobals include request, post, and get. We will be working with these in the lessons to follow. In this part of the course, we're going to be discussing how to process HTML form data using PHP. The concepts explored here are very important because web pages interact with users using forms. Form data can be used for many things. We can insert data into a database. We can email form data to our users, such as a confirmation email or a thank you note. We can also use form data to perform arithmetic, or perhaps a combination of any of these purposes. Form processing starts as soon as we fill out an HTML form and click the Submit button. At this stage in the course, you should be familiar with creating HTML forms. We know that the form element has an action attribute. In our HTML course, we did just about everything except assign a value to our action attribute. It's the action that brings our form to life. The action of our form will point to a PHP script. In addition to instructing our server on what to do with the form data, the PHP script can also validate the form. This means we can check things like email addresses or phone numbers to make sure they're in the right format. We can also check to make sure that form inputs are not left empty or put limits on how much data can be inputted. These are just a few examples. PHP form validation is done on the server, meaning it's the most effective form validation available. We did some JavaScript validation in the JavaScript course, but we also pointed out that JavaScript can be turned off by the user because it's a client-side programming language, not a server-side. PHP validation cannot be turned off, making it the safest way to test form inputs for data accuracy. We'll be exploring two ways to transmit data to our PHP script from our HTML form: the get method and the post method. In both methods, the data is transmitted in an array that is automatically generated. The array holds the key and value pairs. The keys are the name of the form controls, and the value is the data inputted by the user. We'll come back to this when we start creating our form. There's some important points to note about post versus get before we begin. The get method passes our array variables through the URL parameter. The get method should only be used for sending non-sensitive data. Never send passwords through the get method. All variables are displayed openly in the URL. The get method has limits on how much information can be sent. The current limit is 2,000 characters. Now the post method passes variables using the HTTP post method. The post method is much more secure because variables are not displayed in the URL. Information that is passed is invisible to others because it's embedded within the body of the HTTP request. It has no limits as to the amount of information we can send. And this method is preferred by developers. In this lesson, we'll link an HTML form with a PHP script. We'll also explore the difference between the post and get method to transmit data. As you can see in our HTML form, we have two inputs. Both inputs have a name attribute. The first input's name attribute is set to fname. The second is set to email. Our form action is set to send.php using the post method. Now, if you're following along with this tutorial, you'll need to create a file called send.php and save it in the same directory as your HTML form page. So I've saved my page that contains this form as forms.php. I also have a send.php file, and I've saved it in both files in the same directory. Remember, we're saving these files in the folder called PHP Lessons. Now in the send.php file, we have a first name and email text label. Next to each label, we have an echo statement that outputs the information the user filled into the form. To do this, we use an echo statement with a superglobal post variable that contains the information typed into each input. So remember that we use the post method to send the data to this send.php script. So that post data is stored in the superglobal variable post. One other important thing to point out here is in our square brackets, we have the same name that was used in our name attribute corresponding to each input. So the first name input we called fname, and the second we called email. So it's very important to make sure that that is identical inside the square brackets in your superglobal post variable. It is case sensitive, and it must be an exact match. Otherwise, your data will not be sent to the send.php file properly. So just make sure that it's identical. Okay, so now let's test out this file. So open the forms.php file in your web browser using the localhost URL. Okay, and the page should look like this with two inputs. Now just type some information into the inputs and click submit. You should see the data outputted on the send.php page. And so that tells you that you've done everything correctly. You'll notice that the transmission of the data from the form to the PHP file was invisible to the user. Now let's try the get method. We'll change our send method to get. And just make sure you save the file after you make the change. Now go to your send.php file and also update the Superglobal post variable to get. And save. Now in my web browser, I'm just going to go back and refresh the form page and plug in some different information. Press submit again. So we can see that the output is the same, meaning it's the first name we put in and the email we inputted. So the functionality is identical, but if you take a look at the URL, you can see the variables and the values all in plain sight. So fname is equal to Dan and email is equal to Dan at gmail.com. So right there you can see why the get method is quite insecure, especially if, for example, the user is entering a password they'd like to use on your system. Then the password will also be transmitted in the URL in plain sight. So for any kind of sensitive information, if your form is dealing with any kind of personal sensitive information, stay away from the get method and stick to the post method. In this lesson, we'll be programming a PHP script that outputs data a user has inputted into a form on the same page as the form. The PHP script will also do some basic validation that will program into a function. We'll do the following to all inputted data. We'll pass variables through PHP's HTML special characters function to make sure data is transmitted securely. We'll use the trim function to strip any unnecessary characters such as extra space, tabs, or breaks inserted into the input fields. We'll use the strip lashes function to remove any backslashes from user inputted data. This helps add an additional layer of security and protects data integrity. Before we get started, I'll show you a demonstration of the end result. You'll notice right now, under the heading User Input, there's no information next to the field labels. When I press Submit, we can see that the data that was inputted into the form has now been outputted on the same page next to these text labels. Since the PHP variables are sent to the same page as the form, we'll need to use the post method coupled with our form action set to the Superglobal Variable server. We'll get to that in just a second. So let's go ahead and get started. The file used in this lecture is available in the Downloads folder. The HTML you see here is just a basic table that contains all our form elements. So right now, there's no PHP in the script. You can take a moment to go through it. It's just a form, and inside the form there's a table, and it contains all of our form labels, our inputs, and our buttons. We've already named each input, so we can see here, next to the text label name, we have the name input. And this input has the name attribute set to name. Next we have website, and website, this input has its name attribute set to website. followed by position, experience. Now, employment status, we've set it to e-status, just to be more efficient. Comments, the name is set to comments. And then we have our two buttons. The first thing we'll do is create our form action. So what you're going to do is you're going to type the following into the action attribute in your form element. Okay, so it's a little bit long. The global variable server will send the submitted data to the same file as the existing file. We've embedded the global variable server in an HTML special characters function. And this provides an additional layer of security by preventing anyone from injecting malicious JavaScript code into the transmitted data. So it's important to include that. And you'll see that the global server variable is set to PHP self. So this is what allows us to transmit this data to the same page that we're working on. And that's going to output the information on the same page as well. Our method is already set to post, so we don't have to worry about that. So let's go ahead and start with our PHP script. So create your PHP tags. We'll need to define the variables that we'll use to contain the inputted form data. So enter the following variables. And we're going to set each one of these variables to an empty value for now. And you'll see that the variable names we've used are the same names as the names that we've given our input fields. Now we'll have to create a function to validate the inputted data. And so you're going to go ahead and create this function. Okay, so we've called this function val, and this function has one argument called data. There's three statements in this function. The first statement will trim the data. So it'll remove any unnecessary spaces. And then it'll remove any unnecessary backslashes using strip lashes. And we're securing the data by using the HTML special characters function as well. So these are the three basic ways we'll be validating the data. So next we'll create an if statement that checks whether the user has submitted the form. And we'll do this using the server request method you'll see in a second. Okay, so you're going to go ahead and type in the following block of code. So you can see that we've set the global server variable here to request method, which equals post. And what this does is it checks to see if any data has been posted. And the only way data would have been posted is if somebody had clicked the submit button. Now, if the data has been posted, then we've created a series of variables. Remember, we defined these variables up here and we set it to an empty value. Well, if the form has been submitted, these variables will now take on new values. So the name variable will take the value in the name field. The website variable will take the information and put it into the website field, and so on. And you can see that all this data will be retrieved using the post Superglobal variable. Now that information will be stored in our new variable. We've also enclosed our post superglobal variable in the function that we created, the val function. And so each variable is going to be validated using the 3 validation techniques we'd specified in the function. The last thing we need to do is just create the output, and we'll do that using the PHP echo statements. This was the demo file. I'm just going to switch now to this new file that we're working with. So enter this block of code underneath your form, your closing form tag. And this is fairly straightforward. It's just a series of echo statements that is going to output the information that the user is inputted. So once you've entered that block, save your file and refresh your page. And just test to see if it works. Okay, it looks like it's working fine. So we can see that all the data that was inputted into the form has now been outputted on the same page. In the next lesson, we'll be working with additional types of validation techniques. In this lesson, we're going to add additional validation to our form. We're going to make it so that users must fill in their name and website in order to submit the form. If they leave the fields empty, an error message will be displayed. To do this, we'll be using the empty function. So let's get started. Our error messages will be displayed in red. So first, we need to create a style sheet with a class that will change the font color to red. So just create this block of code in your head tag, basically a style sheet with the error class, which will change the font color to red. Now we can create our validation. We need the validation statements to execute as soon as the form is submitted. We also want the data outputted only if the required fields are completed. So remember, this is our output section, and we only want the values outputted if the fields name and website are not empty. So that's the objective here. So first, begin by inserting the following block of code inside your first if statement. So we're nesting one if statement into another. And I'll explain what this means in just a second. So I'm just going to format it so it looks a bit cleaner. Okay, so we've inserted an if statement. And before I explain what each statement does, I'm just going to make sure I close this if statement, otherwise the script won't work. So always remember to close all your open if statements. Okay, so we've created our first line here, states that if the first name field is left empty, to echo an error message stating that the first name is required. There's a second condition. If the website field is left empty, then echo another error message stating that the website is required. If both the name and the website field have been filled in by the user, then the code inside the else statement will be executed. And that basically means that the data that the user inputted will be outputted in our web page. Okay, and so that's it. We've added 2 additional validation components to this script. Now let's go ahead and test the file. So I'm purposely going to leave everything empty and press the submit button. So you can see that now none of the information has been outputted because validation has failed and an error has been outputted. The error is that the first name is required. So if we enter our first name, let's see what happens if we press submit. Okay, now it's stating that the website is required. And I'll just change the formatting of this error so it matches the first one. Okay, so now it passed the first test. The first name was inputted, but it failed the second test. The website is required. So if we enter the first name and the website, and then press submit, then validation checks out and all the data is outputted. Okay, and you'll notice that the comments field was left empty, and that's fine because we didn't add any validation onto the comments field. Only the name and website had additional validation. In this lesson, we'll explore ways to further validate inputted data. We'll start with the preg-match function. We've added a new else-if statement to our previous document as shown here. We can use the preg-match function to test whether a string meets a specified pattern. In our case, we'll test to make sure that the name only contains letters and whitespace. This will prevent someone from typing in numbers in the first name. We've also added another else-if statement using the preg-match function again. This time, it checks to make sure the inputted website is in the correct format. For example, www.mywebsite.com would be an acceptable format. So let's test our script out to see the result. We'll start by typing numbers in the first name. So we can see that the error now outputs name can only contain letters. Now we'll type the wrong website format. So we can see the error, website is in the wrong format. And when the name contains only letters and the website is in the correct format, we can see that the submission works and the data is outputted.